This video demonstrates how to generate interaction terms in Stata and in R, and how to interpret the results. So first in Stata, I'm going to pull in the general social survey dataset. I'm going to create my log. I'm going to examine the relationship between years of education, having children, and gender. And so as always, we're first going to examine the variables of interest. And when we do this, we can see that education has some missing values coded as -99. I'm going to want to recode these as system missing. So I'm going to do that here and check the results. You can see that these have been recoded. First, I archived the old coding of the variable just in case something went wrong. Next, I'm going to examine children and gender. You can see these are both binary variables. So kids takes on a value of 1 if you've had 1 or more children, and then female takes on a value of 1 if you're a woman. So next, we run our bivariate regression, examining the effect of having children on years of education. And so the results show that having 1 or more children has a statistically significant negative effect on your years of schooling. In particular, on average, it decreases your years of schooling by approximately 1.19 years. So, next we're going to control for gender. So being female itself doesn't have a statistically significant effect on your years of education. However, having children still has a statistically significant negative effect. So perhaps we think the effect of having children on education is conditional on gender. So we want to add an interaction term so that we can explicitly model for this. There's a few ways to do this in Stata. This is probably the most efficient way. We can see that our interaction term shows that there is a statistically significant conditional effect. Our parent terms, even though we haven't explicitly written them into the code, have been included in the analyses, and they are statistically significant. So you can also manually compute the interaction term. I can show you how to do this here. You can examine the interaction term that we've generated. So when you do this, you have to include the parent terms manually in your regression. So we've included kids, female, and then our interaction term. And we can see that the results themselves are exactly the same. The display is slightly different, but otherwise the substance of the results is exactly identical. So in terms of interpretation, we have 4 basic categories. We have childless males, we have males who have had at least 1 child, we have females who have never had children, and we have females who have had at least 1 child. So this constant represents childless males, so when everything else is 0. So childless males have on average about 13.83 years of schooling. So males with kids what we would do to find this intercept is set kids equal to 1. So we add 13.83 approximately with our negative 0.69, and we get about 13.14. So males who have had at least one child have on average 13.14 years of schooling. This is their intercept. And then for females who are childless, we set female equal to 1, kids equal to 0, and so we have the constant plus the female to get our intercept for childless females. And this adds up to be about 14.54 years of schooling. And then our final category is females who have had at least one child, and all of these will be set to 1. So when we add these terms together, we get an intercept that is approximately 12.87. So we can see that females who have had children have on average the lowest amounts of education. So next I'm going to show you how to generate interaction terms in R, and how to create a plot to display the interaction results. So I'm going to do this by installing the package sjplot. And I already have this installed in R, so I'm going to first remove it so I can show you guys one more time how to install packages in R. So first we set our working directory. I'm going to remove this package. And I'm going to use the install packages function. And I'm going to scroll down to USA and Maryland. Select OK. And now I need to call the libraries for all the packages that I'm going to need. I'm going to use Stargazer again to generate the LaTeX code for my tables. Foreign to open the stata data file. And then I need to call sjplot, which I just installed. And then also the library car, and this provides a recode function. So I'm going to show you how to recode the education variable in R like I did in Stata. So I'm going to pull in my unrecoded data file. So once you've installed the car and you call the library, you can use this recode function and tell it the name of the variable, and so we're just going to set the negative 99s to be on A's. This line of code will recode the education variable. And just like in Stata, we're going to want to look at basic descriptive statistics of our variables of interest. We're going to output this code into LaTeX, so we can just copy and paste this into the shell that we've generated for you and saved on ELMS. So first I'm going to run the same simple bivariate regression model, examining the effect of children on years of education. And you can see that having kids has the same statistically significant negative effect on years of schooling. The results are the same as they were in Stata. Once again, this creates your LaTeX code, which we can just copy and paste into our shell to create this table. So next we're going to add females. So once again, female doesn't have a statistically significant effect on years of education. However, just the same as before, having children has a negative and statistically significant effect on years of education. So again, we think that the effect of children on education is maybe conditional on gender. So we're going to want to create a interaction term. And we can generate an interaction term in R a few different ways, just like we can do it a few different ways in Stata. Here is one way. So we've included the parent terms, kids and female, and then we've just created this interaction by separating the two parent terms by a colon. And you can see we get the same results that we got when we ran this model in Stata. So here's an equivalent way that is a little bit more efficient. Again, you don't have to have all the terms. You just run female times kids. And at this point, I'm adding this x equals true. And what that means is it's going to return the corresponding components of the model matrix. This is going to allow me to run this next bit of line, but otherwise it's no different, so it helps me generate the plot. And also another thing, instead of having these dollar signs after the data set before your variable names, alternatively what you can do is just have the variable names and then comma and then call the data set. So this tells R to look inside this data set for these variables, the same way that we did with this. So whichever way you prefer, you could do. So if I run this, you can see again, even though we haven't included all the terms, we just have this multiplicative term. It shows females, kids, and then our interaction term, female and kids. And again, the results are exactly the same as the model above, and the same results substantively that we got from Stata. So now I'm going to generate a graph. And what this graph shows us is this differing effect of children. So this graph itself is a little bit messy. So I'm going to show you some code to clean it up, make it a little bit prettier. You can do a lot of different things with this SJplot. So So this looks a lot nicer. It's easier to interpret. And so what this is showing us in this difference here are males who have children and females who have children. So children is along the x-axis, so a value of 1 means having at least 1 or more children. And so this starts out with 13.83, which is our intercept. And then this result comes from adding our beta 1. And our beta 1 decreased it to about 13.14 years, because the coefficient on beta 1 about -0.7. And then the effect of having children, though, for females is going to be beta 1 plus beta 3 times female. So this would mean the decrease is about -1.67. And so that takes it down to about 12.16. So you see, if you add this and this, we get about -1.67. So it's an easy way to display that type of graphical result. And again, we can add our models together in one table and copy and paste this code into LaTeX. So for further documentation on SJPlot, you can go to this website,